Dear students, welcome to my YouTube channel PCM Academy, and we are going to start a new course, that is crash course on IIT JAM Physics. And basically in this course we will discuss the formulas. Okay, so you have to take the short notes of these formulas, that will be very helpful for your revision purpose. Okay, so let us start with the topics of mechanics and GPM, then we will discuss all 7 topics that is in syllabus in IIT JAM. Okay, so first let us discuss about a very important topics, that is velocity and acceleration in different coordinate system. You know, there are various types of coordinate system, something like plane polar coordinate system, cylindrical coordinate system, spherical coordinate system, and you have to remember the formula, the expression of velocity and acceleration in all the 3 coordinate system. Though according to syllabus, you can, if you see the syllabus, then you can see now only 2 terms are there, that is plane polar coordinate and cylindrical coordinate, but you should know the velocity and acceleration in spherical coordinate also, but the expression is much more complicated than plane polar and cylindrical coordinate. So let me discuss one by one. Okay, so in plane polar coordinate system, you know, we need 2 coordinate. Okay, and you know the relation between the Cartesian coordinate system and the plane polar coordinate system. So let me tell you, if this is our coordinate system, suppose rectangular coordinate system, suppose this is your x axis and this is your y axis, and if we have a point P here, x comma y, and the position vector of this P is r, then you know, and if theta is the angle between this r and the initial line, that is your x axis, then this point can also be written as r comma theta also in polar coordinate system. Okay, so this point can be represented by x comma y, that is in terms of Cartesian coordinate system, or in terms of polar coordinate system, that is in r comma theta. And obviously there is a relation between x, y and r theta, and you know the relation is x is equal to r cos theta, simply x is equal to r cos theta and y is equal to r sin theta. So this is a very basic thing that you know, r sin theta. But what we have to remember here, what is the velocity of this of a particle, or if you talk about this P, at this point P, if there is a particle and the particle is moving along this plane, on this plane, then what is the velocity and acceleration in this coordinate system? Okay, so obviously this velocity have 2 component. One is r component, that is along r cap direction, that is along the increasing direction of r, that is in this direction. So let me write it again here. So if the point P is moving, or the particle P is moving, suppose this is our x coordinate system, this is a y coordinate system, and the particle is moving here, suppose along this direction. So if this is the anytime position P, okay, then you know, if this is r, then this increasing direction is r cap, and increasing direction of theta is theta cap, just theta cap. So obviously the velocity has 2 component, one is along r cap and another is along theta cap. Okay, so the velocity v will be, you can write in this way, that v r cap plus v theta theta cap, and this vr is nothing but r dot, that means dr by dt. R dot means dr by dt, there is r dot r cap plus r theta dot theta cap. Theta dot means d theta by dt. So please remember this result. Okay, so the component, radial component vr is simply r dot, that means this is dr by dt simply. Okay, and if you talk about the transverse component, that is v theta, and v theta is just r theta dot, and that is r into d theta by dt, and this is sometimes called as omega also, angular velocity. So you should remember these 2 components. Similarly, you have to remember the component of accelerations also. So acceleration also have 2 components, one is radial component and this transverse component. So if you talk about A, then it also have 2 components, one is a r cap and another is a theta theta cap. Okay, and ar is nothing but r double dot minus r theta dot square. You should remember this, into r cap plus a theta. For a theta it will be r theta double dot plus 2 r dot theta dot plus 2 r dot theta dot theta dot. Okay, that means here also we have 2 components, one is the radial component and another is the transverse component, and the radial component ar is nothing but r double dot minus r theta dot square. Double dot means 2 times the derivative of r and obviously a theta is nothing but 2r dot theta dot plus r theta double dot, or you can write r theta double dot plus 2r dot theta. Okay, so this is how you should remember the component of acceleration and the velocity in plane polar coordinate system. Okay, similarly you can remember from this expression very easily for cylindrical coordinate also, because only there one component is will be add, and that will be z component. Okay, so you know, for cylindrical coordinate system we have rho, phi and z. We have rho, phi and z, and this is same as this rho can be treated. If you compare with polar coordinate system, then you should understand very easily. So you should compare this rho with r and phi with theta. Okay, and this z is in the axis along z axis. So what is the basic relation between rho, phi and z and the xy z? So here 3-dimensional coordinate system you can say. So you can relate this rho, phi, z with xy z. Okay, so if you have a cylindrical coordinate system, something like this, suppose we have a cylindrical coordinate system. So suppose this is our x axis, this is our y axis, and this is our z axis. Then what is rho and what is phi? Suppose there is a point on xy plane P. So this is actually rho, you can say. Okay, so something like this, and this is z actually. This is z, this is rho, and this angle is phi. So you can see in xy plane, this is same as plane polar coordinate system, because x is equal to, you can see, rho cos phi, and y is equal to, you can see, rho sin phi, and simple z is equal to z. So your conversion formula is just x is equal to rho cos phi and y is equal to rho sin phi, and z is equal to just z simple. So instead of r, we should replace by rho. Okay, so what will be the velocity? The velocity component, that will be just v r cap, v rho cap, you can write in this way, just v rho cap, and v phi cap, and plus just v z cap, similar to the previous one, that is v r and v theta. So what will be v rho? V rho will be just rho dot, that means d rho upon dt. So rho dot rho cap plus v phi means rho phi dot phi cap. Okay, plus one component is more, that is z dot z cap. So this is how you can write v, velocity. Similarly, you can write acceleration also, comparing the previous one, and acceleration is just nothing but what the acceleration was. You can see here was r double dot minus r theta dot square. So instead of r, we can write rho. So it will be rho double dot minus rho phi dot square. Okay, and that will be just double dot, this is phi dot square, and into rho cap plus you have rho phi double dot plus 2 rho dot phi dot, okay, into phi cap, and one more component, that is z double dot into z cap. So you have to just add this component, otherwise the expression is same. You have to just replace rho by r and phi with theta. Okay, then you can easily write down the velocity and acceleration in cylindrical coordinate system comparing with the plane polar coordinate system. But for spherical polar coordinate system, this is much more complicated. Okay, so let us see that thing also. Okay, so now let us first tell you what is the conversion formula from Cartesian to polar. Okay, so here also we have 3-dimensional system xyz. Now if you talk about the coordinate system, something like this, x, y and z, and we will use x, y, z to r theta phi here. Okay, so what is r? First let me define what is r theta and phi. So suppose we have a point P here in coordinate system, which have the coordinate x, y and z, and what will be r theta phi? R is the distance from this origin to this point P simply. So this is our r, and theta is the angle between z and this r, that is theta. And what is rho? Rho, if you take the projection of r on xy plane, so if you take the projection of r, okay, on xy plane, then this angle is basically phi. So what is your conversion formula? You can see simply z is equal to r cos theta. You can write here simply. First let me write z. Okay, this is very easy. Z is equal to r cos theta. And if you see what is the component of r along this direction, so this is the projection of r along here. So if this angle is theta, so this is 90 minus theta. Okay, so I think this will be r sin theta. And this is 90 minus theta, so it will be r sin theta. And what will be the component of r sin theta along y axis and along x axis? So along x axis it will be r sin theta cos phi, and along y axis it is just r sin theta sin phi. So this is our conversion formula. So our y will be just r sin theta sin phi, and x will be just r sin theta cos phi. So this is our conversion formula. Just this is actually position coordinate in terms of r, theta and phi. Now what will be the velocity and acceleration? This is more important. So again here also velocity of three component, that is first radial component, that is v r r cap, then it will be v theta theta cap, and then it will be v phi phi cap. Here the expression is more complicated. Let me write it. Okay, so what is vr? So first two terms will be same, so it will be just r dot r cap, and then v theta is just r theta dot theta cap. Okay, so one more term will be here, and v phi, here v phi is just r sin theta phi dot, so phi cap. So you have to remember extra this term r sin theta phi dot. But the expression will be more complicated for acceleration. So what will be the acceleration? Acceleration will also have three component, that is you have a r r cap plus a theta theta cap plus a phi phi cap. Okay, now what is the expression of ar? Okay, so expression of ar is just first two term will be same, that is r double dot minus r theta dot square. We already have this term for plane polar coordinate also, but the extra term is here minus r phi dot square sin square theta. This term is extra here into r cap. Plus if you talk about a theta, again we have the term 2r dot theta dot plus r theta double dot. This term we already have for the plane polar coordinate system, and the extra term is minus r sin theta into cos phi phi dot square into theta cap. And the last term, that is completing the new term for a phi, and that is plus, let me write here, that is 2 r dot phi dot sin theta plus 2 r cos theta theta dot and phi dot plus r sin theta phi double dot. Okay, so this is the phi cap along phi cap. So this is much more complicated result. You don't need to remember this result, because this is not very useful for your exam purpose. You can remember this result just. Okay, this result. This is just one extra time you have to remember. But according to syllabus, if you see the syllabus, so in the syllabus there is only plane polar coordinate and the cylindrical coordinate system, and that is very easy. Okay, so you have to remember this term. So this is the first topics of according to our syllabus, that is the different coordinate system. But you can see, if you see the syllabus, you can see the first in mechanics, the first line is that the Newton's law and the application of it. So that is basically the 10+2 level syllabus. So you should remember, if you talk about the IIT JAM syllabus, then your 40% syllabus is JEE main advanced syllabus. So you should go through that syllabus also for your from your 11th and 12th book. Okay, and I should remember, I should tell you the book that you can use is a very good book, that is the AC Verma. So you have to practice the AC Verma. Okay, and then your 40% preparation will be ready, and that is that you already have studied in your 10+2 level. The concepts are same, but you should practice the problem from AC Verma book. Then your 40% preparation will be completed, and then the rest topics that you have studied in your graduation syllabus or in your BSc honors syllabus, then you should go through that. And the formula, I will tell you everything according to your syllabus. All the formulas I will tell you, and you should take the notes of each and every formula, and then practice the previous year problems. Okay, so then you should give a test series also, but first thing you should remember all the formulas and the previous year questions. So I will solve previous year question later on, but you can try yourself now with this formula. Okay, so this is your first topic. Then I will discuss about the Newton's law. Newton's law, that is the basic background of mechanics that you have already studied in your 10+2 level. So I will discuss in the next video that thing. So for today, this 3 coordinate system and the velocity and acceleration 3 coordinate system is enough for you. Okay, thank you.